All right, here we go.
All right, so I believe we are officially live now. So welcome to our thank you for joining us. First of all, our new web series, our weekly Texas Sky update. So my name is Ashley. I am a science educator and console operator at the University of North Texas Sky Theater, and I'll be moderating the comments off to the side. Just so our presenter can answer any questions that you might have. I'm going to relay those questions to him that he can answer in the live stream. Anything about space and astronomy. So our presenter will be using software today called Stellarium, which is a free program you can download at home on your computer to explore the skies. I will share the link in the comments as well as after the video ends on our Facebook page. Our weekly Sky update is completely free to view and anytime after this stream ends. However, since we are not running in-person live shows in our planetarium, which is really sad at the moment, due to the world's pandemic, it has left us without any kind of revenue or any way to generate that revenue. So if you'd like to help out to sustain and advance our program here, you can do so by donating. Again, I'll be providing a link in the comments for you if you would like to donate. But if you're unable to donate, please raise awareness by liking and sharing these live videos to your friends and family so we can spread it across the community here. So with all that being said, I would like to finally introduce you to our Star Talk presenter, Cade. Today he'll be talking about our summer solstice, which is, I believe, officially today. Also some of our planets that are out tonight and some things that we can see in our sky tonight. All right, Cade.
All right, thanks a lot, Ashley. Very cool. So what we're going to be doing now is switching over to Stellarium. Stellarium is a really fun program, and like Ashley said, it is free to use. So I'm going to be using Stellarium, and I kind of have it set up a little bit already. So what I'm going to do here, you can already see I've got the date and the time open up. I'm going to actually change the date and the time to be closer to right now. So I'm going to roll back the clock a bit. And then if you've seen previous videos, you know that it's pretty easy to use Stellarium. You just left click and drag around here, and then you can zoom in and out to kind of get a nice better view of what you're looking at there. But here it usually starts you off facing the southern portion of the sky, and then you can hover over the bottom part of the screen or to the left part of the screen to bring up the date and the time window, which is how I was able to control the date and the time there. And the location window is also important. My location is retrieved from my network right here. That's what it says, get location from network. But you can also, of course, change this to be from the perspective of anywhere in the world. So I'm going to close that there. And then I have a few other settings that I've updated. If you're curious of what settings I use, you can watch our previous videos that are saved onto the Sky Theater page, and you should be able to get a good idea of what settings I use. But I don't change too many things. So I'm just going to left click and drag around here, and the first thing I'm going to do is face north. You've got your cardinal directions along the horizon, which is that curved bit at the bottom there. And then I'm going to go ahead and actually change the date and the time. I'm going to change it to be about 10:30 tonight, and we're facing north, so at about 10:30, that's when it's going to be a really nice level of darkness. Of course, today is the summer solstice as well. So the summer solstice means that we have, the longest period of daytime in the year. So this means from our perspective here on Earth, in the northern hemisphere at least, summer is now beginning. However, in the southern hemisphere, winter is now beginning. And that's just because it is on, of course, the bottom side of the planet, and we have this nice 23.5 degree tilt. And that's what gives us our seasons, is that axial tilt. That's what at least gives us fall and spring. If we weren't tilted, or if we were tilted directly at the sun, we would only have two extreme seasons of like very, very harsh summer and very, very harsh winter. But thanks to this nice tilt, we have these wonderful in-between seasons known as spring and fall. And that makes it a lot easier for really our environment to be sustained here on Earth. So our summer solstice is our longest period of daytime. So the winter solstice would be the shortest period of daytime, or longest period of night that we have here on Earth. And that is, of course, relative. There are places very far north that have, daytime for 24 hours or nighttime for over 24 hours. But here in Denton, Texas, we get the longest period of daytime today. And so from today leading up to December 20th or December 21st, the amount of daytime we have will decrease, and then it will increase again after that. It also has to do with the sun's relative position to us and where it looks like it is in the sky. So summer solstice is pretty cool stuff. I'll talk a little bit more about that here in a moment when I show you some more things in the night sky. For now, I'm going to close out the date and the time window. And what we can also see here, of course, while we're facing north, is the North Star. It's a really important point. It's pretty tough to see, though, at least in this view, because you have so many stars here, you're not quite sure what it is. But if you're in Denton, Texas, and you're going out and looking at the night sky tonight, if it's not too cloudy, usually when you're facing north, it's going to be kind of a star that's not too bright, and it's mostly by itself. It's actually this one right here. One way you can find the North Star is, of course, by using the Big Dipper, which is this group of stars over here. I'm going to just scroll in to zoom in a little bit here. And we are still facing north. But the Big Dipper up here is this group of 7 stars right there. I'm going to click on one of them, and then I'm just going to hit C to turn on the constellation for that star. Oh, here, I think I have to hit W to clear these out. There we go. All right. So this full constellation right here is Ursa Major. That's what it's known as. However, this 7 group of stars right here is the Big Dipper. These 2 stars right here are the pointer stars, which point us directly at Polaris, the North Star. The North Star, of course, is not particularly bright or close, but it is still. It never moves. It's kind of stagnant, and that's pretty cool. At least it allows us to track all of the other night sky stars with respect to Polaris. And one of the ways that we do this, you can see by hovering over the bottom menu here, and you can turn on the equatorial grid or the azimuthal grid, one of these here, will show you a good representation of some grid systems that we use to keep track of night sky stars and planets and other cool objects. So this one right here looks the most like the celestial sphere, which is kind of like if we took our latitude and our longitude lines and we just projected them out into space. From this perspective here, our origin would be Polaris. I'm just going to turn it off to make it easier to see the stars. But here what we can see is that if we actually speed up time, which you could do by opening up the date and the time window, or you can use this little fast forward and play toggle right here. If we speed up time, you'll notice all the stars in the night sky will rotate around Polaris. And the reason this happens is because, of course, the North Star is located directly above the North Pole. So our planet Earth here is actually pointed at and facing the North Star. So that's pretty cool. It's very convenient for us, and it's allowed us to actually keep track of night sky objects for the last several thousand years, so that we've been able to create calendars and keep track of time. We connected the dots in all these constellations, and we attributed lots of different mythology and stories to them, depending on the various cultures, of course, where you're from. And we attached these stories to them so that as we went out at night, when we didn't have TV or radio or anything like that, we would have stories to tell about the things we could see in the night sky. But now we can use them for lots of other cool things too. So next what we're going to do is we're going to actually be able to see a few of the cool things that are in the night sky tonight that are not in the northern region of space. I'm going to bring us a little bit towards the east here, and the reason for that is because our summer triangle is actually coming into focus. Our summer triangle, now that it is summer, is actually 3 really bright stars that you can see all summer long, as well as later into the seasons. So they consist of Vega right here, which is in the constellation of Lyra the Harp, Altair, which is in the constellation of, I believe, Aquila the Eagle, and then Deneb, which is this one right here, which is in Cygnus the Swan. Cygnus the Swan is also sometimes known as the Northern Cross, where the shorter end right here actually points you kind of north. I'll zoom out a little bit so you can see that. There's, I believe that is the Little Dipper right here. Yes, that is the Little Dipper right there. Alright, and these three stars right here are extremely bright. If you don't recall from previous videos that we've done, the size of the actual star in the Stellarium program represents its brightness. And you can see that over here on the left where I have magnitude. Magnitude is considered a lot like a golf score, so the lower the magnitude, the brighter the object is. So Vega right here is 000, and then this one right here is 1.25. So, and you can see, of course, that Vega has been made to be a bit larger than Deneb right here. But these three stars right here are the Summer Triangle, and it's just a nickname that they're given because this group of stars, or these three constellations, pop up every summer. And they're located along the Milky Way. The Milky Way, of course, is the galaxy that we all occupy, that our solar system is in. And the Milky Way is very cool. It's very difficult to see the Milky Way, of course, unless you're very far away from light pollution. Light pollution being, you know, any kind of street light or car light that we leave on at night to see outside. Our eyes actually focus on any light that's produced near us, so it makes it impossible for us to actually see light that comes from the Milky Way or from light years to millions of light years away. If you want to get a good view of the night sky, you have to simulate it in a program like this, or at a place like the planetarium, or go out to an observatory or somewhere like that. Alright, now over here in the eastern to southern portion of the night sky, something else you'll be able to see tonight are planets. Last week and 2 weeks ago, our planets were really only out late into the night. Tonight, around 10:30, however, you should be able to see, or even actually, yeah, 10:30 at the earliest, they'll probably be rising. I believe that we've gone forward in time here a little bit, so let's double check our date and time window. Yeah, we're around midnight 30 now. But even at 10:30 or so, I believe is when they'll be rising. There we go, yeah. Right out of the southeast, you'll be able to see Jupiter and Saturn.
Hey, Cade.
Yeah, what's up, Ashley?
So I do have a question.
Cool.
I know there's a bit of a lag in the whole Facebook stream, but I just want to relay this question to you. When you have time, you can answer it.
Go ahead.
All right. So Robert Foster, he commented on the Race Astronomy Facebook page. He asked, "Has Earth's tilt changed since it's settled? Do we think it might change in the future?"
Cool. Awesome question. Thanks, Robert. So yes, Earth's tilt has changed. And the actual numbers here, I'm going to kind of just go off of memory, but you can Google this a bit more if you'd like. So Earth spins a lot like a top on a table. Something else that happens to a top on a table, or a quarter, as it spins, it starts to wobble. So what this is called in astronomy, or in the planets, is precession. So what we experience, and just to answer this question, I'm going to click back to face the northern sky. So right now, Earth's axial tilt is pointed right here at Polaris. However, there's another star that we actually wobble towards, and this happens around the cycle of this is around, I believe, 12,000 years. So it takes around 6,000 years for us to actually change North Stars. The North Star that we wobble back and forth between is Polaris here, and the other one, I'm just going to use Control F in our software and look this up, is Thuban is the name of the star. And I know it's in Draco, but I'm not sure exactly where it is. There it is. So we wobble back and forth between these two stars, and this is called precession. There are lots of simulations of this on YouTube and other places like that. Hopefully you'll be able to find some more information about it online. But let me know if that answered your question or if that didn't answer your question. So we wobble like a top on a table, or a planet does at least, and we wobble back and forth between these 2 points. This is also one of the reasons that astrology has been considered by a lot of physicists and scientists to be outdated. Because a lot of the astrological calendars are used based on stars or star systems from 2,000 to 3,000 years ago. And even though our wobble is pretty subtle, that still will make a dramatic change on where, for example, the sun will be located in respect to, you know, other stars. Of course, not to offend anyone's beliefs, that's only a faith-based practice, and that's one thing that astronomers just like to heavily, emphasize. Is just that that's one of the reasons that astrology is no longer considered a science. It was several thousand years ago, but it's no longer considered one today. All right, so I'm going to W clear out all of the constellations here and bring us back over towards the southern sky. Jupiter and Saturn are going to be out. If you're out way later into the night, like 3 or 4 in the morning, Mars will also pop out of the east there. I'm going to zoom in a bit, and what we'll be able to see, is that Jupiter is in the constellation of Sagittarius here. But if we zoom in further on Jupiter, we can see all 4 of the Galilean moons right now. There's Callisto, Europa, Io, and Ganymede. And we can see the great red spot on Jupiter right there. If we fast forward a little bit, or let time go on, we can watch Jupiter kind of move around its own axis, which is pretty cool. If you got any more questions about Jupiter or planets or anything like that, feel free to toss them in the comments. We love answering questions. That's our job. And there you can see a nice view of Io actually transiting over the surface of Jupiter there. It's pretty cool. Stellarium's a really fun program. You can learn a lot and do a lot of cool stuff with it. If you're wondering where the moon is right now, the moon is actually located right next to the sun. So here we've cruised on into the morning. I'm going to rewind us. The moon is located right next to the sun right now, so you can really only see it super early in the morning. Otherwise it's very difficult to see. Besides that, I'm going to show you a few other constellations that you can see in the southern portion of the night sky. Tonight, I'm just going to type in the nighttime. Let's go 20, and then 22. Very cool. Scorpius, of course, is out tonight. There's Antares, not Mars. It's a great nickname for a star right there. Other constellations that you can see tonight, there is Virgo. Excuse me. And of course, on the other side of Virgo over here, we have Leo the Lion, recognized by its backwards shaped question mark looking mane there. Sometimes it looks like a mouse to some people, where this is the head of the mouse and this is the tail right here. There are 88 constellations in total. You can see about a third on any given night. That is covering the majority of what we have to talk about today. I am going to do a brief little talk on deep sky objects. Right now, there was a new magnetar that was actually recently discovered. A magnetar is a type of neutron star that has a very dense, in fact the densest possible, magnetic field. A neutron star is when you have a giant star collapse at the end of its life cycle. And when this giant star collapses, what is left is just an incredibly dense, tiny little star, a neutron star. And this neutron star is something on the order of like 6 to 10 masses of the sun, but it's only like 6 miles in radius. It's incredibly tiny. It's the smallest star that I know of. I could be mistaken. A white dwarf might be smaller, but I'm pretty sure this is the most dense and compactly made star that exists in the universe that we know of. Recent ones were just discovered, and it's pretty cool. We're able to study them using, or detect them using gravitational waves and other forms of spectroscopy, as well as another form of detection, and gravitational lensing as well. What I'm just going to show you right now are a few different little clusters and cool things that we can see tonight. If you have a high-powered telescope, or if you're going to be messing around with Stellarium or some other software, there's a lot of nebulae, of course, in the Milky Way galaxy, and in the region of where Jupiter and Saturn are going to be, and Sagittarius and Scorpio. I'm just going to check out the Eagle Nebula right now, which is a pretty cool one. Stellarium is loaded with a lot of really cool little HD renderings and images of nebulae and star clusters and other cool stuff like that. If you're wondering what this is that we're looking at here, the Eagle Nebula is a nebula which is a big vast cloud of gas and dust. This gas and dust is mainly ionized hydrogen. That's what all this pink stuff is, at least. It's ionized hydrogen. And what happens a lot of times is over time gravity will come into play and will condense lots of pockets of this gas and dust down into one little central area. And this pocket will increase in size, and its gravitational pull will also increase, and of course its mass does as well. As all these things happen, it tries to achieve electromagnetic equilibrium. And when this happens, it usually will explode and try to take the shape of a sphere. It's just all of its matter as condensely packed as possible. And then what ends up happening is it produces light and heat. These are baby stars. When these baby stars or protostars are formed in these big, vast clouds of gas called nebulae, they will have these big disks that form around them, and they'll actually protrude jets of gas from their tops and bottoms. So it's this huge event, and it looks pretty spectacular. We've actually only very recently witnessed it for the first time with telescopes. This happened, I believe, in December or January, but it's very, very cool. There's images of protostellar jets now that we've officially captured. It's very neat stuff. All right. Besides that nebula, you can of course see lots of other things over here. This is the Sagittarius star cloud, which I believe is a globular cluster. Globular clusters are groups of stars that range into the thousands or millions of stars that are all grouped into one spot. Here we got the Lagoon Nebula, which has some absorption or dark nebula in here as well, which is basically just dark gas that's in front of light gas that's absorbing the light gas behind it. Pretty cool stuff. All right, we're nearing the end of our program for today. We're going to stay online for a few minutes longer in case anybody has any questions or anything like that. Ashley, are there any other questions in the comments right now?
Not from what I see.
Cool.
I think we're good.
Right on. Well, if you do have questions about this stuff, or if you see this video later on and you have a question about it, feel free to type a question into the comments or message us. We will also be live again on Wednesday night. We are going to be doing trivia. Ashley and I will be back, and we are going to be hosting Trivia Night. Trivia Night is going to be really cool. I'm really excited about it. I believe our theme this week is Moon and Planets. Does that sound right to you?
Yes. Planets and their moons. Is it going to be trivia night? I believe is it during the day?
I think it's night. It's at 7 o'clock
No.
Wednesday night. Yep, 7 o'clock Wednesday night. We'll be hosting trivia. And on top of that, we will have some prizes. The prizes for trivia winners, I believe, are going to be determined. Is that correct, Ashley?
Yeah. We did have our previous winner, I believe his name was James, last weekend, or just past week. He was the winner of our first Kahoot quiz, live quiz game, and he won a free live show, either online stream or in-person live show. So, but of course, our in-person live show is kind of to be determined date. So
Right.
it shows you can either choose between an in-person live show or an online stream show.
That's right.
That was one of our prizes.
Yeah, so for Wednesday night, if you are the winner, you'll get to choose if you want to wait until we reopen after the pandemic. You could see an in-person show, or we can do a live show catered just to you over the internet, and you can be the only audience member if you'd like. We have some other cool prizes that we're cooking up for you, and we also have some other live video content and pre-made video content we're going to be adding to our Facebook page and our YouTube channel as well. So we got lots of other cool content coming out soon. Thanks a lot for hanging out with us and supporting us.
Oh,
And
I think we
go ahead.
got another question.
Sweet.
Let's see. Paul M. Sawyer on the Race Urban Astronomy page. He asked, what about the solar eclipse? I think there is one this summer.
What about a solar eclipse?
Yeah.
Yes, I believe that there was one in... Oh, shoot, I can't remember where. I know there's going to be one in Massachusetts next year. Cannot remember exactly where. There may have been one this year. What we can do real quick, and this might be a little bit of cheating, but Stellarium is pretty cool. I'm going to do Control F and look for the moon real quick.
Yeah.
And then I'm just going to get rid of the ground here and the atmosphere. There we go. There's the moon. What we can do here is we can roll around through and watch the moon move and see when we're going to get an eclipse. That's of course always a possibility. If you don't enjoy getting seasick, however, you can just kind of scroll around and check out when we might be getting an eclipse. I'm not entirely sure, but I want to say that we are not going to get one this year, but we would be able to see one in Boston, I believe in July. Well, what I'm going to do is I'm going to figure out when our next eclipse is, and we will comment back to you in the video comments. Unfortunately, I think it would probably take me a few minutes too long to figure out when our next solar eclipse is using Stellarium, but what we can do is we can at least find out and tell you right now. Ashley, do you know when our next eclipse is?
No, I'm actually kind of looking it up now.
Cool, thank you.
Yeah. So...
Well, I was playing around with Stellarium the other day, and we were able to see one from Boston around 6 a.m., and that was at the beginning of July. But I don't think that we're going to get one in Texas this year. I thought that there was going to be one early next year, but I'm not sure. But we'll at the very least get back to your question in the comments.
Yeah.
Cool. Thank you so much for hanging out with us today. Feel free to ask us more questions, or you know, if you got more video kind of content that you're curious about in terms of the stars, ask us about it. We're going to be making lots of new content for you, so let us know. All right. Without any further ado, thanks a lot, and if you can, please consider donating and supporting our page. Cool. Hope you have a great weekend.
Bye, guys.